Welcome! In this video I'm going to be taking a look at this Eiiev 12.8 volt 100 amp hour lithium iron phosphate battery. So this was provided to me by the distributor, but they're not compensating me for this video and they're not reviewing it before I post it. If you find this video helpful and you want to purchase one of these, I'll put a link to it in the description, and if you use that link it helps me out a little bit and doesn't cost you anything extra. So let's get this open. So this is a Group 31 battery, so it's similar in size to a car battery, although this is not a direct replacement for a car battery. Here we have a manual. We have terminal bolts and caps of the battery. There's a strap on it. Let's see if I can pull that out. Let me get this off my bench. So there we have the battery. Let's take a look at the manual. Now I may not cover everything in here. You want to read through it on your own. So here we have the specs. You can pause and read through that. So this is 1280 watt hours. Life cycle is greater than or equal to 4,000 times. Weight on this is 25.3 pounds. So if you compare this to a lead acid battery, this is going to be a lot lighter. Now this is lithium iron phosphate chemistry, and it's 100 amp hours. And with lithium iron phosphate, you can use pretty much the whole capacity of the battery, whereas with lead acid, you can only use about 50% of that. So if you had a 100 amp hour battery that was lead acid, you'd probably need about 2 of these just to equal up the capacity, usable capacity of this. So not only is this lighter than a single lead acid, it's much lighter than enough lead acid that would have a similar capacity. So this has the dimensions here. The terminal size is M8, so it's a 1.25 thread pitch. So we have some advantages here. One advantage is the battery voltage stays above 12.5 volts at 90% discharge. Here we have warranty policy, charging tips. So you want to use a charger that's compatible with lithium iron phosphate batteries. Now these can be connected in parallel. So you want to charge the batteries separately, then you want to connect them one by one in parallel and leave them together for 12 to 24 hours. Then you can connect your batteries in series and in parallel. So you want to connect them together and let them even out if there's any differences in the voltage. They should be super close together though when you connect them. So this is talking about the BMS. It has a high temp disconnect of 167 degrees Fahrenheit, has over and undercharge functions. So if the protection kicks in, you want to leave it for 30 seconds, set it aside, and let it reset itself. This talks about if the battery's reading 0. So sometimes these batteries could go to sleep, like if you're leaving them for a long time, and they'll go to 0 volts. And if they do that, you want to get a charger that can boost it up, or you can connect it to a solar panel. And then we have some other notes here. Looks like that's about it. So it has plastic caps on here. I'll pull these off. And then we have bolts. So these have a washer and a lock washer. So I'm going to put those in there finger tight. Let's get a meter out. So I'll switch this to 20 volts. Get my polarity right. And we're at 13.38 volts. So we have charge in there now. So I'm going to go ahead and tighten these. Now these can take a number 3 Phillips screwdriver in the top. I'm not going to wrench these down super tight because I'm just going to be charging them. And there are a number of different chargers. I just have this 4 amp charger. It's not a super fast charger, but it's common on chargers like this. You need to plug it in first. And then I'll go to the mode and I will choose 12 volt LFP. And then once it's chosen on the charger, I'll connect up the clamps. It doesn't really matter on this if it's positive or negative first, but so this looks like it's a 4 amp max charger. If you look in here, it says the recommended charge rate is 25 amps. So you can charge this at a lot faster rate than this charger here. But this is just what I have sitting here. So this is a 100 amp hour battery. 25 amp would charge it in about 4 hours or so. So I'm going to let this charge up and then we'll come back and we'll test it out. Okay, so this is finished charging and it's showing 0.55 kilowatt hours on my kilowatt here. So this isn't going to be 100% efficient charging it, but we maybe put in maybe like 500 watt hours. So when you are charging it, you do want to make sure you keep the charger on it for the full charge, at least on occasion, so it can make sure it can level out those cells. So if the cells are out of balance, it's good to charge it up to 100% on occasion, because that's when it's going to balance those cells. So next I'll get this set up in an application where we can test it. Okay, so I have some equipment here. I'm going to connect this up. I have the battery, I have an inverter, and I have an air cleaner. So a couple things to point out here is that you should typically install a fuse here. I don't have a fuse for this right now. I'm going to be very careful not to short this out. But typically on a setup like this, you want a fuse. So I'm going to connect these leads to the inverter first, and this is a 1000 watt inverter. Now I'm going to connect these up to the battery. I'll connect the positive up first. Now I'm going to torque these. I didn't see a torque designation in the manual, but based on my experience, I'm guessing this will be around 8 Newton meters. So I have a little torque wrench here. I'll go to 8, and this is a 13mm socket. Now I want to make sure I don't bridge these terminals here, so I'll just tighten this down. Until it clicks. Now for the negative side, I'm going to use a pre-charge resistor. Now this is a small inverter, so it's probably not a huge deal. This is a 50 watt, 8 ohm resistor. So I'm going to hold that on here, and then I'm going to touch this to the terminal. If you don't use one of these, you might see a little spark. So I'll just hold that on there for a second, and that will charge up the capacitors in the inverter. And now I can put this on. And I really should just put this cap on. Okay, so it's very important to tighten these down properly. If you don't, you could have some overheating, or you could break the terminals. So I have this power monitor here. I'll plug this in the end. Of course, that does not fit in very well. I'm going to use this adapter to space it out. And I'll plug the air filter in here. And I'll plug this in the inverter. Now I can turn the inverter on, and I'll turn the air cleaner on. Turn that off for a second. So I'm going to let this run down, and we'll come back and we'll take a look at the energy monitor. Okay, so the air cleaner is off and the battery is depleted. Let's head over to the computer and look at the results from the energy monitor. Okay, so this first chart is the total consumption. So this started at 3:43 and ended at 7:06. So if I look at a time duration calculator, I got 15 hours and 23 minutes. So if we go to the top here, we can look at the total consumption, which is 1165 watt hours. So the battery's rated for 1280, so that puts us at 91%. So that would be the efficiency of the inverter. So I think that's pretty good. So if we look at the next chart, this is going to show the wattage consumed. Now there's spikes here at the beginning. Now it's a little higher here at the beginning. I had originally turned this on high and then I changed it to low because I didn't want it to turn off in the middle of the night. So this ran at about 76 watts. If we go down here later, it dropped to maybe 75 watts. And then finally we have the voltage. This is the output of the inverter. And it's at 108 volts, but then it kind of drops down to 107 volts and it kind of does this little sawtooth kind of pattern, especially towards the end. But it's pretty stable. Now I don't have an easy way to measure the exact capacity of the battery, but the fact that we put 91% of that power into the air cleaner through an inverter, I think is a good sign that we're getting that 1280 watt hours, or at least very close to it. So I'm going to charge this back up and then we'll demonstrate some more things. Okay, so I have the battery all charged up, and here I've installed this cord. So this has some leads on it and it has a 12 volt socket, similar to what you'd find in a car. So over here I have a 12 volt fridge, which you might plug into a car, but you can also plug it into this battery. So I'll plug this in here, and now this is on. So the display is on, and this can run. And I've measured this before, and this is around 55 watts or so when it's running. We'll just say 50 watts when it's running. So this is 1280 watt hours. So I don't have a meter on here to tell me how full the battery is or how much power I'm using. But a battery like this, in my experience, will easily run this for a weekend. So if I go camping for a weekend, I could put this in the back of my car. I can plug this into the battery and power the fridge over the weekend, no problem. Depending on the temperature, could probably even run it longer than that. Now, an advantage of this over something like a portable power station is that there's not a lot of extra electronics in here with the display and with the inverter and all those other things. This is just 12 volts going right into your fridge, so you're not going to have lots of conversion losses you would with a traditional portable power station. This is a very efficient way to run a portable fridge like this. So if you're to take this camping, you could have an adapter on it like this, and you could plug in a car charger for a phone or a laptop, and you can get a tremendous amount of charges out of a big battery like this on a laptop or a phone. Now, if you plug in a phone charger, it's probably best to unplug it when you're not using it because those can have a real slight standby draw, or you could add a switch to this. But an adapter like this that you wire on can be very handy. So those are just a couple of use cases for a lithium iron phosphate battery like this. When we first hooked it up to an inverter, that's a setup like you could use for emergency power if there's a power outage in your home, or you could set up a setup like that in your van for van life. Now, if you want to put this in an RV, you can just swap out your lead acid battery with this, but you may need to do some things like upgrade your power converter to lithium iron phosphate. And if you're pretty handy, that wouldn't be a super difficult task. Now, if you do a lot of camping out of the back of your car, a battery like this would be great for powering a portable fridge, maybe an air mattress inflator, charging phones and laptops and things like that, and other things that take 12 volt power. Now, if you have an application that uses a lead acid battery, there's a big advantage of a battery like this because it's going to weigh a lot less and have more usable capacity. So that's the Eiiev 12.8 volt 100 amp hour lithium iron phosphate battery. That's all I'm going to cover in this video. If you have any questions, please leave them in the comments. If you liked this video, please click like. If you haven't subscribed to my channel, I'd appreciate if you could do that. And thanks for watching. Until next time, goodbye.